Hi, I'm Kevin Swiger with VPG Micro-Measurements, and today I'd like to show you this instrument. This is the MM01 StudentDAQ. It's a little USB device that can measure strain in quarter bridge, half bridge, and full bridge. And in addition to strain, of course, being a millivolt per volt device, you can also measure force with a load cell. And I'm also going to show you today how to measure temperature using one of our RTDs in a Lst network. So very quickly here, we'll hook up the MM01. I'm going to connect my quarter bridge strain gauge, and we'll start the software. Okay, so all I need to do is select my bridge type, in this case a quarter bridge, enter my gauge factor, and we're scaled to measure directly in units of microstrain. I'm going to do one more thing here, and that's adjust the full scale range on this chart so that you can actually see the strain. I'm going to apply by hand. And we're going to zero the device, and we'll start scanning. So we're measuring strain directly in units of microstrain. Of course, we can record this at up to 80 samples per second and save the data right to an Excel file. Okay, so let me stop this. I'm going to show you now how to measure force with this MM01. I'm going to connect the load cell. Now this load cell is a full bridge device. And of course, we're going to set it up to measure in the units of pounds force. So we're going to go here, we're going to change our bridge type to full bridge. We're going to set some custom units, which the software permits. And I'm going to change this to LBF for pounds force. Now, calibration information is published on most load cells where you get it with a data sheet. In this case, this is 1.806 millivolt per volt per pound force. Actually, per pound force would be 0.1806 since it has a full scale of 10 pounds. So with that connected, we're going to select our custom units here in software, and I'm going to enter a full scale range of 10 pounds, and we're going to zero our load cell, and we'll begin scanning. So now very quickly I've converted to measure in units of pounds force. As I press on this load cell, I can pull on it as well. You can measure both tension and compressive forces. Okay, one more thing to show you, and that is temperature. So I'm going to disconnect my load cell here, and I'm going to show you something on our website. This is the VPG Micro-Measurements website, and if you start from the home page, to get to this temperature sensor, you go to strain gauges. Down at the bottom here, you'll see RTDs, temperature RTDs. And this is the device that I'm going to use today. I'm using an ETG50B with an option W. And that's installed on this piece of aluminum. You'll notice that it's very much like a strain gauge. It's constructed of similar materials. It's bonded the same as a strain gauge, and that's good because it means it responds to temperature at the same rate as your strain gauge. Also in use here is an Lst Matching Network. This is also on our website. What this network does is it linearizes the response of nickel with temperature and presents a balanced half bridge to your strain indicator. And it also scales it. For example, in this case, this device I'm using here will scale it to 10 microstrain per degree Fahrenheit. So let me show you how this works. Again, very easy to set up on the MM01 with the software that's included. We're going to stop scanning here. This device is a half bridge. So we've done a quarter bridge, a full bridge, now we're going to do a half bridge. I'm going to set custom units in this case to degrees Fahrenheit. And the scaling on this is 0.005 millivolts per volt per degree Fahrenheit. Again, we're going to use our custom units, and I'm going to set the full scale here as 5 degrees because I'm just going to use my hand to show you this. Now, the only thing to do is to zero it. In this case, we're going to look at a differential temperature instead of an absolute temperature. So I could read a single point here. I can begin scanning. Go ahead and hook up the device. Again, this connection to the strain indicator is a half bridge. Zero again here. Okay, so we're going to begin scanning, and now you can see we're measuring temperature. If I warm it with my hand, I'll raise this up so you can see it. If I warm it with my hand, we're going to see an increase in temperature, and then when I let go, we're going to see it start to ramp back down. So this is a resolution of about 1/2 degree. This thing can resolve 1/10 of a degree Fahrenheit. Thank you very much.